Welcome everyone to the next session of Rails Conference, Remote Edition 2020. I will be your host for this next talk about Lifecycle events, the Circle of Lifecycle events by Nelson Bradley Wittwer. A little about myself. Who am I? I currently work at a company called MX. We write banking software, APIs, web apps, mobile apps for banks, credit unions, and fintechs. So we serve the biggest names in all of those categories. Have over 20 million users at the moment and growing like mad, even with the world as it is, the way that it is today with the virus and all of that. It's great to work in an environment at Rails at scale, and I'm really grateful for the opportunity to see how far Rails can leverage itself. I hate all the memes that say that Rails don't scale because I tell you that they do, that it does. So I've also worked at Rails in a lot of startups. So I tried my hand at the startup lottery a couple times. Have yet to really cash out on that sucker yet, but I believe. What is a lifecycle event? And going back to the topic of our talk today, right? Rather than, I think, just diving into a bunch of technical jargon, I'm a really visual learner, so you're going to see me use a lot of visual aids, memes, and the like, as I feel that it's a great way to take something that's familiar to explain a complex subject. So if you weren't able to pick up the clues from that video, let me explain. So when something happens in your platform, a new user is created, Simba is born, there is likely a chain of events that you want to write within your application for something to happen. So these things could happen on a user create, on an update, at a destroy. There's likely some things that you will write in your software based off of those events. And these lifecycle events are a super powerful and important thing to get right. And it's also one of the easiest things to shoot yourself in the foot with, in my experience. So I thought I would share some of my experiences both on a scale in the millions and scale of the I'm trying to get my startup off the ground, how does this work, type of contexts. Speaking of startups, so Rails has this brand of being like the go-to framework in startups, even today, years and years after its initial launch. And there's a couple of reasons why startups in particular gravitate towards Rails. It's very easy to prototype on something. You can run Rails new and run a couple scaffolds and have a very basic CRUD application up and running very quickly. But in specific, there's two things that I think that really help the back-end layer of Rails marry super well with a brand new product that you're trying to prototype or release or iterate on. And it's what makes it very fast to develop with. And that's the way that Rails sits on top of Postgres, any sort of relational database that Active Record can tie into, the way that it super simply handles model associations. So a blog post can have many comments, right? Or an author can write a blog post. And so you can have these relational models that are super easy to work with, tie together and draw associations with and build a beautiful view on top of, which I super love. And then tied within here, as you start to expand on the behavior of your applications, writing callbacks that trigger during a lifecycle event of any of those models is a super powerful way to build an app. And in fact, that's what back in my startup life, those two tools and a super simple UI did most of the heavy lifting. So I thought I would, rather than dealing with the abstract, diving into the content of this talk, my favorite tech talks are the ones that have a shared domain, a shared problem that we're trying to solve. So since I've talked about my startup experience before, I thought I would, pitch you my idea here. So let me pitch you my next startup. It's going to be huge, and I think you're going to love it. I'm going to call it the blockchain credit. We're going to do credit scores on the blockchain. Because why not? It's 2020. We should absolutely have credit reporting within a blockchain that is peer verified. And if that wasn't enough for you, we're also going to do machine learning. Oh, and there's going to be a hell of a lot of AI in this thing. It's working. It's a unicorn already. You gotta get on the ground level while you still can, right? But you know what? There's one more thing I can do to simplify this pitch. You know what? Yeah, just drop the blockchain credit. I think it's a lot cleaner. Okay, so here's how I'm going to pitch the technical side of this to you. So there's a couple of things that we want to have happen when users sign up for our platform. So number one, we would need to create a credit score for this user, because what's the point of having the blockchain if there's nothing to store on it, right? We want to create an alert profile, so something to track. Hey, do I prefer alerts on my email for my credit report? Do I want it in a text message, a tweet, a TikTok, or whatever, right? And then we want to send a welcome email. Welcome to the beautiful land of blockchain credit. Very reasonable expectations, right? So let's take a look at how this flow might work. So let's say we have an administrator in our platform in Rails, and they want to create a new user. Okay, that's pretty simple. We can create one user, but create an alert profile, create a credit score, and then we're going to return that back. And we also want to send out this welcome email. Like that flow, very reasonable for a web application. So if I were to spin up a Rails scaffold, that part's pretty simple. But what about all these steps right here? Where do those go? Where's the chapter on the Rails tutorial about that, right? And that's where we introduce our first actor, active support callbacks.
Hello. Oh, beautiful. Looks like a Christmas tree.
This is how I felt about it. Like I said, you take models and you give me an easy way to tie into all those lifecycle events. That's all I needed to flesh out my ideas. And in our little startup in our Rails app here, it's going to be no different. So my naive implementation in my early startup days might look something like this. I have a user. It's going to have a couple of things that take place after we create. So after we create a user, we're going to create our alert profile, we're going to send our welcome email and our credit score, and we are done, right? Easy peasy. So if this is your first stop in Rails callbacks and lifecycle events, I thought I would take a quick second to dive a little bit into the documentation here to explain where and when to use these to make sure I'm not losing anybody. These first two steps here with these little hyphens, these are the functions methods that are called that trigger the callbacks that fall underneath them, right? So if I were to say user.save, then these callbacks 1 through 7 would follow in the order that you see here. If I were to check to see if a model is valid, so if I say user.valid, then the next step would follow. So let's take an example. So if we were trying to do some debugging here and we were having a hard time validating our users and we're using Slack for some reason instead of like a test or a console, there's an example. I don't use this one a super ton, but it's there if you need to plug in before you do any validation checking. So after you validate something, or at this point, this is where we're going to actually validate it. So we're going to, let's say we have a email validation on here that we require a user to have an email address before we can save their record. So after validation, maybe we want to log it and say, yes, this user did have a valid email address. Then we have before save and before create. So these are used a lot more frequently in my experience. So after the validations have taken place and before we save, or before we save could be like from an update, before create is specifically for creating a new record. What are some things that we want to have? So before create, again, more logging here, but a more practical example is this set modified by. Let's say we were wanting to do write some auditing in here to make sure that we record whoever created a user. Maybe it's to give a salesperson commission or something like that. Like these lifecycle events are super important because people's livelihoods could be on the line. And this is an example of that, right? So we're going to say that I modified this user, so I'm going to have this set modified by callback that we can attach before we save a record. So then we get to everything that happens after we create something. So these are a lot more practical as well, because maybe after we create something, that's when we blast our sales channel that we have a new sale or a new sign up in Slack, right? Again, these are a little bit more abstract, but the idea is you can write whatever custom logic you want in these various stages of the life cycle. So of creating, of updating. So the pros of callbacks, super easy to use. They pair really well with validations, and they're very easy to test in an isolated manner. And as a bonus, they run at every database operation with inactive records. So no matter how you are saving something, let's say you're in a Rails console or you've built a view in your signups controller, or maybe have a different controller that does like bulk processing. All of those, no matter which way you're creating a user, they're all going to fire the callbacks, which is super helpful. The con of a callbacks is they run every time. So it's kind of a double-edged sword. Like it is a pro, but maybe sometimes you don't want to run all of that complex logic. Maybe you want to bypass it because we're trying to do a bulk import, for instance. We don't want to send them all a welcome email, or maybe their welcome email needs to have specific instructions or something like that, right? So tying those into the database itself is tricky because they're going to run every time. They have a potential for race conditions, and this is where I've been bitten a lot as I rely too many times, especially when they give you that level of granularity. It's very easy to write logic that gets out of order. Maybe some developer doesn't realize the intricate order of all of the logic that needs to take place during your callbacks, and so you can have a race condition. And again, complex conditional logic, you're not going to know, like if you're depending on some sort of one callback running before the other, or one association being in place, but it's not yet, it can get very complex. And here's a terrible joke about race conditions. And if you're not familiar with a race condition, the idea is you might be expecting it to be in one place, but it happens somewhere else, or it happens later than you thought, right? And that happens all the time with poorly written callbacks. And that's the crux of what I want to talk about today is to how to write these lifecycle events that are going to happen, that Rails gives you beautiful tools to tie into in a way that's going to treat that's going to be easy to maintain and maintain your happiness over time as well. So our example here, let's start with our pro tip of the day, because my example is a very terrible example. And my pro tip for you is callbacks should only modify the model that they are defined on. So we had these associated models, right? We had a user, we had a credit score, we had an alert profile. I want you to take away from this talk this point. Callback should only modify the model that they are defined on. So a user should only modify a user. You shouldn't actually be creating an associated record in a callback, because for the reasons that I've just talked about with my cons, this is going to lead you down a rabbit hole of debugging in the future. Just you wait. I know it's easy and you can write it and the code will work, but as you expand upon your software, this is going to be your biggest point of friction. So let me kind of explain this visually here, right? So active record, this beautiful interface that we have that sits on top of a relational database. This is how our database is going to view our data in very separately defined tables. But it's not going to know about all of the war crimes that our application has committed, because this is how our application is going to look if we implement our software the way that I showed you within our callbacks. They're all kind of like come together in this giant mass of a snowball that's, why do we even have separate files for all of these? Because if they're so interconnected and related to each other, there's no separation of concerns or responsibility. This is a common theme within experienced software developers, those who have read a lot of books on refactoring and software design. Every model should be responsible for itself and not for its associations. Callbacks is a great way that we can accidentally blur those lines and bring everything together, where there's not a single principle of responsibility that each of these models has. So why no multi-model modification callbacks? So like I said, model responsibilities are not respected. Everything is all kind of mushed together. And this kind of comes back to the hypothetical before. What if we want to create a user that doesn't get a welcome email? Maybe it's like a white label deal and they don't want to have the same email that goes out to them, right? What if the credit score creation process needs to vary from one user to another? So if you're doing a giant if statement for that condition, all tied within a complex callback with different models, it's going to get super hairy super fast. And what if we want to change the behavior that happens when a new user signs up, but we want to maintain what the older users had, or maybe we have a new product that we're spinning up, we want a new API that versions it. If you're doing that, the callback later in the models, it's going to be super gnarly for you to be able to tackle that. I haven't hit this point home enough for you yet. Let me do I only have one more trick up my sleeve as a millennial to really make you consider the impact here, and that is to give you an Instagram beautiful picture with cursive with this quote, because that's what we do. Damn. Callbacks should only modify the model that they are defined on. Okay, so our example here of creating an alert profile, a welcome email, and a credit score, this breaks our test. No sufrio. This is bad because we're modifying associated models than the user. Callbacks for a user should only modify the user. So, common question that I get when I'm explaining this concept is, does that mean I can't use associations in callbacks then? Because I love them. That you were saying, Nelson, that's what makes Rails so productive as an iteration platform. The answer is yes, you can use associations as long as they are read-only. So in this case, if we're going to update the status of our user after we've saved or after we've committed to the database a change, we can do that in a read-only fashion. So in this case, we're accessing the associated credit score of this user, but we're just checking to see if their credit is good, because we can English, apparently. So we're not modifying the credit score. We're not deleting our credit score, but we're just checking on it, right? So that's all right, because we're just reading. We're not modifying that credit score. So a couple more examples. So let's say we have a transaction. We've paid off a loan. We've created a new loan. We've accrued interest, etc. Because it's a credit application. So after a transaction happens, this is a very common pattern. We need to update a user's credit score. This is a very naive implementation. And this reads super well. Like, I could open up this code and be able to know exactly where to look. But let me show you how terrible things can get if we crack open this callback. Okay, so at least it's readable because these method names are very Englishable. But let's take a look from we'll wear our debugging hat and try to see into the future where things could break. So after a transaction, we want to, oh, holy cow, look at this. We need to have some way of checking the debt of this transaction. So that's another associated model that we're going to have to take account of. And then we're going to have to see if it was paid on time. And then based off of that, we either increase the credit score or decrease the credit score. Again, this business logic is all sound. And if it were just these crimes, I think we could probably squeeze by for now and assume this technical debt. But now we're going to do another check of their credit ratio. Again, another associated model that we're going to have to take, or at least we'll have to look at their credit score and then view all of their transactions to view their ratio. And all this is going to take place during every transaction. Again, we could probably sneak by, but now we've got some conditional returns in here. Oh, because yeah, test users happen all the time. Demo users, we gotta be able to pitch to get our next deal, right? Oh, and then apparently nepotism. I mean, it wouldn't be a fintech product without some good old fashioned American nepotism. That would totally happen. Oh, holy cow! Now we're reporting to external services, credit services. Experian, credit bureaus, that makes sense. Oh, and some dark web pirates. So that all assumes that all of these actors are online and accepting transaction updates. And then lastly, at the end here, we're going to check to see if our user's got an alert profile. And if it does, then we're going to send them a transaction alert. Holy cow. So there's a lot of things that can go wrong within this callback. What happens to your transaction if none of those services are up? How do I debug? And the weird example of it's my nephew's debt ratio that's too high. Should they actually get an email or not? Like, should all of this happen at every transaction that I just open up within a Rails console? Oh, I'm exhausted by this. So the only serene option here is you should only modify the model that is defined on that callback, right? So please do not. I know you can write it and it will actually, the software will work, but over time you're setting yourself up for failure with that giant transaction example, because that's what will happen over time with software that is getting used. This is a bug ticket that was just assigned to me, and this is going to be a great bug because it has this terrible word that starts the ticket off of sometimes. Sometimes new users aren't getting welcome emails. So that sucks. Or in this ticket, we haven't been given instructions to how to recreate it. So that's going to be painful. And we know that it's going to be tied within this user sign-up process because it's a welcome email. We know that's where that callback was written. So we have to dive in. So why would this happen? So I think my first thing that I would do is I'd open up a Rails console. Maybe I'd see their alert profile and just see if anything weird's going on. Oh, but look at this. There's not one. Okay, that makes sense. What should have happened to a user? Should a user exist within our platform if they don't have an alert profile? Should it have been created at all? What happens when we try to send an alert to that user in the future? How do we ensure that all three objects are created? So the user, the credit score, the alert profile. How do we ensure that all three of those things were created at sign up? How do we fix this code smell that I've been hounding on for the past 10 minutes and fix our bug? One of my favorite tools in Rails, the active record transaction for handling my associated models that I love so much. Let me show you how this sucker works. So a transaction is a block that basically says anything that takes place in this block, if there's ever an error in it, we're going to roll everything back. And so nothing is going to be written to the database. It's going to be an undo. So let's say our user was created. That's all fine and good. But if our credit profile fails to be created, then the user above it also is deleted, and that doesn't actually get created as well. So to answer our other hypothetical, should a user be able to exist in our platform without an alert profile? I'd say no. That's part of our sign-up process. It needs to be there. So yeah, these transactions are super helpful because it's either all of this code happens or none of it. So everything within this block, either it has to take place or none of it. So the mechanism it triggers that rollback with is an error that gets raised. And that's why I'm calling I'm super excited to create these records, create with a bang syntax, because rather than defaulting to Rails validation API with its like user.errors to be able to inspect why my user wasn't valid, I actually want to skip that and raise an application error so that my transaction will roll back. Super cool. So if I use one of those, now when a user signs up, even with my nasty callback, we at least now know that all three of these users, or all three of these objects, will be created at registration. But where in theory should that transaction fit? Should it fit in the model? Should it fit in the controller? We already talked that it shouldn't live in that callback because it's modifying other objects. And this is where I'm going to harken to this popular Rails post that has seen many different iterations over time. And that's, should you have a fat model or a fat controller, fat model and a skinny controller? And I'd actually argue that nothing should be fat. Everything should be skinny. Hold on. Let's take a moment to salute Weird Al, the American hero, for this great gem. So we know that I don't want to just take this transaction and we definitely want to rip that out of a callback. So a model doesn't seem like the right fit. Should I put this all into a controller? It's right. In this context, it's not a terrible example. Like, this doesn't seem like it's overly complex. But if we were to make this a transaction controller, you can see all that logic. You can see how the responsibility of the controller is getting way out of hand. So a controller should be very skinny. It should process all of its logic to some other entity. Typically it's a model, but in this case, we've already determined that the model is not the correct case for it. So where does it go? So please no model in the callback, please no controller, but where does it go? And that's our next tool, a service object. So my good friend Fancy Nancy, she always says that a service object is just a fancy name for a vanilla Ruby object. So you've got a plain Ruby object, but you have a service object. It's a classier distinction, of course. So here's an example of one. I've abstracted a lot of this stuff, but this is a very simplistic example of what a user service could look like. And you'll notice, unlike all Rails things that are generated, there is no inheritance. This isn't inheriting from something. It makes you feel kind of naked because you're on your own. Everything that you're writing here is not part of the Rails framework, but is part of your business logic. And it's part of the reasons why I love reaching for tools like this, is because your application, your business needs to do something specific to you, and will frequently not fall into the standard CRUD request cycle of a scaffolded object. In our example here, we have got a lot of complex logic. It should live somewhere, and a service object is a great place to live. So just to run through this really quick, so we're going to create, so passing in the params, this will be like from a registration form, all of the fields that we collect, and then we are going to extract from those for the fields that we need for a user param, for alert profiles from our credit score, and then we'll trigger our create objects method here that will utilize our really cool active record transaction. Pretty straightforward. Whether or not you need an object to process that, and you prefer procedural processing, and this is actually what I would prefer, because I think this is a lot more straightforward, and it's a lot more functional, a lot less state to manage. We can just pass the objects that we create in line. Something like this would be my preference. So procedure is like the super sophisticated approach to this. Just having something that some procedure that keeps track of all of your registration process. Versioning gets super simple because you can take your either your service object or your procedure for registration and throw a version on it. So if you need to maintain support for how things used to happen when you signed up users to how things will with your new and improved mobile application, let's say, just increment the version number in this module when you're off to the races. So where should you put a service object, a procedure? Where should you put it? I've seen some people put these type of vanilla Ruby objects in the model directory. And that's fine. Like Rails is going to load them. I personally don't prefer the model directory because models in my mind should be what Rails generate. Like everything there should have an associated database table that goes with it. I prefer to, if I'm doing service objects, to have some sort of other directory for services, or maybe in lib, since it's not part of the Rails traditional app structure. I don't think it really matters. What matters is that your team all has a consistent preference for all of that. So pros of a service object. So single responsibility for everyone. So we're going to have a dedicated object that takes care of user registration. It's one object that its job is to know how all these pieces within our application are glued together. And each piece of our application doesn't need to know about everything else. Like everything has its single responsibility. It's easy to test because we don't have to create a factory bot or something like that, or a fixture that keeps track of the ordering that all of our various associated records need to take place in. No, like a service object or a procedure, it knows that we're going to feed it a param and it's going to feed us out our three objects that we're expecting. Very easy to test. It's super easy to version, like we talked about. Very easy to contain complexities. And again, because you have an object that's sole responsibility is to juggle all of those things, it's easy to have one place that has it all. And we have the option to sidestep this registration process if we ever wanted. If we needed to create just a user by itself without an alert profile or a credit score, we can absolutely do that. And since it's not tied to a callback, we have that flexibility because it's not tied to every database event that takes place for a user. So the cons of a service object. So again, just as the pros of callbacks worked for us, they can also, disassociating them could bite us in time. Like if a developer isn't aware on our team that we have these service objects or procedures that take care of user registration, they just might assume that their alert profile is always going to be there when they create another way to create users within our platform. So there is some training that you're going to have and responsibility that you're going to have to make sure that all of your edge cases are handled. It's not vanilla Rails, so this isn't a subject that Rails boot camps or college courses are going to cover. And if they do, it's going to be like a 30-minute session. But it's a super powerful way to kind of contain the complexity of your logic. The learning curve might be there for a bit, especially if this is your first time kind of dealing with data pipelines, because this type of concept isn't covered in a lot of the educational material. So there will be some training that you're going to have to do. And you're also going to have to figure out how you're going to handle errors. So Rails with callbacks, they pair super well with the validation API, if you build your own service object or your own procedure, you're going to have to either use those existing error models or those existing validation APIs, but find some way of messaging in the controllers of the various consumers of your services that something went wrong. It's just more things you're going to have to think about. But it's good because you should be thinking about all of those things because going back to our earlier bug, should a user be able to exist without an alert profile, right? Like you need to be thinking through all of those things for user registration, but it's just not as easy out of the box as it would be if you're using scaffolding. Okay, so going back to where does our fat, skinny, and models or controllers live? So in this example, our model for a user now looks like this. We don't have any callback that has any logic for it, thankfully. Our controller is just passing off to our user service this create call. So our controller is super skinny, and our service has all of the lifecycle logic that needs to take place in a very easily testable and isolated environment. So our model, our database and our application are now viewing themselves all in the same way, and everything is awesome. because everything is isolated and they all have their own responsibilities. But all of this makes one giant assumption, and that's that all of your logic is taking place within one application. And that brings us to our last chapter.
Hey, hi there, little fella. Come out here. Do you know a way out of here?
So how do we handle lifecycle events in a distributed environment? It could be microservices, or maybe there's just different apps within your platform, right? Let's say our credit app has scaled significantly, so we needed to break these up into multiple apps, of course, because we're at web scale now. So we've got a couple different apps now. So we've got our main credit app, but maybe we've got another app that does business intelligence, one for marketing, one for alerting, and one for sales itself, right? So when we create a user, how do we tell all these various apps about that? And how do we handle these complex lifecycle events in a distributed fashion? And the core idea is where before, when it was all under one hood, we had complete control over the ordering of how these things all happened. In a distributed environment, you have to let go. You have to relinquish the control of all of that and trust that everywhere else in the platform can handle the new information about your record that you are going to tell it. So our job is to tell the system at large that something has happened, and we have to trust them to do what they will with that information. So it looks something like this. We're going to send a message out that a user has created, and then all the gossip within the system is going to take place, right? The only control we have is our text message that we're sending out, is our message of a user update that we're sending out. And the rest of the platform, it's their responsibility to consume that information and make their changes as they see fit. So a couple technical examples that I have technical tools that I've used to implement this idea of messaging on a distributed basis. RabbitMQ and Kafka are great tools to reach for. They each have their pros and their cons. I won't dive too much into what tool you should use. That's for another talk. But what I want to do is give an example of how you deal with these events with these tools at a high level is all. And the idea is we need a publish and a subscribe model. So we're going to publish our lifecycle event out into our platform, and the various apps in our platform are going to consume that message by subscribing to that event topic. So for an example, here's our credit app. We have our user that we're going to serialize to JSON, and then we're going to publish it out to the world. So in a Rabbit example, we will publish it to a topic of like user.create. So any of these consuming applications that are interested in user create events, they're going to subscribe to user creates, and they can do whatever they would like to it. So a CRM, for instance, if we create a user within our app, they will consume that user JSON and maybe create a contact for it, right? And maybe that's something that they would be interested in. And the cool thing is this one user event kind of gets fanned out to everyone, and they all get their own queue to process that data, which is really cool for resiliency. Because if ever our CRM app is down, for instance, I know it's never happened in the history of the world, but if our CRM is down, does that mean that it's going to miss any user JSONs that come in the future? That'd be a bad system, and that's part of the benefit of using a messaging system like this is Rabbit is going to persist all of those messages so that by the time that it comes back up, it can process all of the user messages that it missed while it was down, which is really cool. So an example of that is this. So tying into those callbacks that we talked about earlier. So when we create or update or delete, we want to publish that state to Rabbit or to Kafka or to whatever pub sub service that you use, right? So we're going to publish the state of our self. So in this case, self is a user. So it's going to be a JSON payload. And then our CRM app will consume that message with something like this. This is all kind of just pseudocode. But it's going to listen to any users.create messages, and it will create a new contact, and maybe it will be able to deduce what account in our CRM the contact belongs to based off of the company name of the user or something like that, right? So the responsibility is a lot more distributed now, and this is where the costs of distributing computing really come into play. I don't really have a horse in the monolith versus microservices battle, but I can tell you that distributing computing is a lot more expensive. So make sure you are prepared for the expense in technical complexities and the technical services that you're going to have in place for managing all of them. Because these are a lot more moving pieces, and since you don't have that control of what happens if a user errors out what should happen, if you can't control it, then you're more error prone, and you have to write all sorts of logic to get everything back in state and all resynced. It is possible, just gets more expensive. So the pros of PubSub lifecycle event handling. What's nice is dependent services can go up and down, and they will not miss out on key information, and they shouldn't prevent a user from being created. We can pick up where we left off when the app comes back online. We don't need any service objects or procedures. There's no option for a gnarly callback because we're just going to tell the world about our state and we can move on. Super resilient to downtime, like I talked about. Our queues can keep track of what we've missed when they come back online, and everyone minds their own business. Part of the allure of microservices and distributed apps is that it takes that principle of single responsibility and it kind of takes it up another level. Like our credit app should only be responsible for credit and not for email notifications or CRM integration. I can see where they're coming from with that because it takes that single responsibility and takes it to the next level. The cons are it's super easy to get out of sync, especially if you're running into problems with, let's say there's a data problem with users. Like, how are you going to handle updating that problem within your database and in your app, and then telling all the distributed apps that, hey, everything that we did in the past, we need you to undo everything. It can get kind of complex. My recommendation is to make all of your consumers idempotent. So that means you can process the same message over and over and over again without doing any harm. So that if you have to get things back in sync, you can just rebroadcast the state of your database across everything as a worst case scenario. And that's totally fine. It's just, again, more complexity that you're going to have to keep in the back of your head. Super susceptible to race conditions and orphans, even more so than our callbacks example from before, because there's different places where all of this logic and state can live. So if you are dependent on different consumers for creating different objects and then broadcasting those out for other people to consume, it can get really gnarly. And it's very easy to enable a distributed monolith. This is an argument that a lot of people who hate microservices really come back to, is that we can have the benefit of splitting up applications, but not really realize that true benefit, because if they're all so tightly integrated within understanding the state of all of the records from all of the different apps, all we've really done is created a giant monolithic app where everyone's dependent on the state of a user. Keep that dependency up and running is this PubSub model that is, as I mentioned before, can be gnarly to keep up. So it can enable it if we're not being vigilant on what our dependencies are. Like, what does our CRM have to know about? Does it need to know about transactions? Does it need to know about credit scores, or does it just need to know about our users, right? And it can be a big old single point of failure. So if Rabbit goes down, all of this fancy distributed architecture that we have built up could crumble pretty quick. So, in review, callbacks. They're beautiful. But the big point is they should not modify other associated records. They should only modify themselves. I beat that dead horse pretty well, I think, during this talk. It's great for setting database fields on that model itself. If you have to use associated models, make sure you're doing so in a read-only manner. Next was our active record transactions. So if you require many records to be created in line and dependent upon each other, use a transaction that you can easily roll back so that you know that you're either getting all of them or none of them. But don't put them in callbacks because that breaks our earlier rules. Our service objects and procedures. So use a service object when you are required to do a series of dependent database calls during a lifecycle event. So lifecycle events are if they have so much business logic that are getting complex and key to your business, I highly recommend creating their own entity to handle user registrations, user deletes, client registrations, all of that should be bottled up into their own file, Ruby file, just to say it as simply as possible. And you could use, if you prefer object architecture, that's great. If you prefer a class method that handles your procedure, that works too. It helps keep your models separate. So if you're not a monolithic architecture and you are into some sort of distributed microservices setup, I recommend using a distributed messaging platform like RabbitMQ or Kafka to broadcast and handle all of your lifecycle events. This is really great for maintaining that boundary of responsibility. It's very resilient to downtime, but it's not immune. In fact, it's more so susceptible for orphans and race conditions. All right, we made it. We got there. We've learned a lot. I had a ton of fun putting this together. I owe a ton to this Rails community at large. In fact, my entire technical career, I think I owe to it because these tools that help me rapidly iterate have given me my career and given me my professional passion as well. And I just wanted to find a way to bottle up all of the things that I've learned over the time to write simpler, more maintainable code and deliver it in this format. So I really appreciate you hanging out with me. If you enjoyed it, here's where you can find me on Twitter. Tell me you enjoyed it. If you laughed at all, let me know, because I derive so much of my worth off of making people chuckle. That would be great. Anyways, thanks for flying with us today, and I will see you next time.